grabar. Está grabando.
Okay.
Okay. Okay. Thank you, Fernando, for making you available for this interview on the Water Action platform. Your article based in your research in the possible seasonality of the coronavirus have a lot of expectation in the network. So we need to know a little bit more about this article, this research that you have produced with your colleagues there in the University of Maryland. So we're going to have this interview around that. But first, please introduce yourself, tell us who you are, what are your expertise and your career and your story.
Sure. No, thank you, Victor. Thanks for the invitation. It's always a delight to talk to you, particularly in this context that we're living today, where the whole world is living something that's really unprecedented. I tell a lot of colleagues that I know of no living person that lived through the last pandemic 100+ years ago. So this is something that we're all living for the first time, and it's caught us a little bit off guard, right? And that's and everybody's running around scrambling, trying to figure out. And I think one of the biggest unknowns is understanding the virus itself, right? And I think that's going to be critical for not only developing a vaccine, which is probably the biggest effort around now, but also understanding what are the conditions that allow the virus to spread. My name is Fernando Miralles-Wilhelm, and I'm a trained hydrologist. I've worked in a number of related fields to water, and I started my career over about 30 years ago. I did a lot of groundwater work originally. I was really interested in that in the late 80s. And my interest in groundwater led me to try to understand how wetland ecosystems behave, because wetland ecosystems are very much driven by groundwater. And then of course I got interested in surface water because of the same topic, because wetlands are sort of a transition ecosystem. And I spent a big part of my career looking at wetlands and how they evolve, how they change, and this also got me interested a little bit in climate issues, and because of sea level rise in coastal areas, again, related to wetlands. So I use wetlands to sort of migrate my career interests towards what I do today, which is primarily interaction between water and climate variables, right? So the way we arrived at COVID was actually quite interesting. It's something that I haven't done before. And the article that you refer to is the first article I have published ever in a medical journal.
That's interesting, because that's an interesting story. How do you get engaged in this?
So it's
being a hydrologist, climatologist. That's interesting.
Yeah, so I'll tell you, it's a little bit of a fascinating story. For me, it was very interesting. So I was sitting at my house on an evening, a Friday evening in March. I think it was March 6th. It was a Friday. It was about 7 p.m. and I get a call on my phone, and it said something like University of Maryland, which is where I work. And I assumed it was someone calling me from work, and it said, "It's Friday, it's 7 p.m. I'm not going to take this call. I'll deal with it later." But maybe a few minutes later, I got an email. So the person that was calling me was a virologist. It's a researcher that works in the Institute for Human Virology, also at the University of Maryland, but someone who had never met before, right? And he was looking, so virologists study the way they study the virus. They study, what the conditions that lead to the virus originating and spreading. This particular researcher, the message said something like, I'm looking at the outbreaks of coronavirus, and at the beginning of March, there were really 3 outbreaks in the world. There was the Wuhan, which is in China, which was the original outbreak, and then there was an outbreak in Italy, and there was an outbreak in Spain. Those were the 3 at that time. And what he told me is that when you look at the latitude of those three, it's pretty much the same. So one question that he wanted to, that a curiosity he had is, could this be related to temperature, right? Because the temperature bands, particularly as the northern hemisphere is changing between winter and spring, which happens at around March, there was a very narrow band of temperature in which these three latitudes fell, right? And of course, you know, as himself as a virologist, he was asking the question. So, for example, in China, why didn't the virus go south from Wuhan? I mean, there were really no cases in the south. There were no cases in Vietnam. There was no cases in other, you know, in other locations where there was a lot of travel. So there was a lot of human transport, but no virus outbreaks, right? So I looked at the data, and because I work with the hydrologic cycle, and temperature is a big part of it. I do work with temperature data sets quite a bit. So I told him I would look at the data. What we did over that weekend, so we worked on Saturday and Sunday to try to gather information of other locations around the world where there were starting to be cases reported, not big outbreaks, but reported cases of the coronavirus. And what we found is that the majority of cases still fell in that band of latitude. So this told us there was something happening there. Something that had to do with the virus itself and with the physics of how it moved. So we did and this I learned from how the medical doctors publish their scientific work, is that they publish what's called they do a pre-publication. So we wrote a paper and we pre-published it. We put it on our website, and this is like what the economists call a working paper. So you publish it and then you can change it and add to it. So then we started from March onwards. We started to look at every outbreak around the world. What was the first case reported, how it grew, and what was the temperature change during that period. And what we found is that for about 50 cities around the world, including cities in the southern hemisphere, and I'll get back to that in a second. There was a sweet spot for virus outbreak. An outbreak means basically when the cases start to grow, okay, at the very, very beginning. So this is not really about the human-to-human transmission, which is still the biggest. So the biggest way to get coronavirus is human-to-human. But the actual conditions that need to exist for the virus to explode do have to have some environmental variables. So we looked at temperature. And the sweet spot was between 5 degrees Celsius and 11 degrees Celsius. And then we also looked at humidity, because the dryness and other viruses have some correlations with humidity. And me being a hydrologist, that's a little bit more of what I do. We also found relative humidities of between 40 and 70%. So not too humid, not too dry, but like in the middle. And we saw that of the 50 cities, a good percentage of them fell in that range. There were some exceptions, like, for example, the southern hemisphere at the beginning, we didn't see much of an outbreak.
But that means now the focus would be in the south hemisphere. I mean, because winter is arriving now there.
Right. So what we're seeing, so for example, what's happening in Argentina, what's happening in Brazil, particularly, what's happening somewhat in Chile too, is that you actually start seeing now
in July.
Winter to spring transition, right? And now the cases are taking off. So this sort of, you know, corroborates our hypothesis, right? So eventually, what ended up happening is that we were able to compile enough empirical evidence that we actually got the paper peer reviewed, and published, and that's how that paper occurred. And since then, we've received lots of inquiries, because we found out that there were several people around the world looking at this climate angle, but but no one had really, found that sweet spot between temperature and humidity.
So there are, you mentioned that there are several people now looking at this. You have been collaborating with some other universities or researchers in
so
this?
we have so we're now there is a one of the more valuable ways to use this information is in predictive modeling. So these epidemiological models that predict outbreaks and predict the so the models that are used to date, no one had ever modified these models to include temperature and humidity. So now we're collaborating with two groups. One at Johns Hopkins University in Baltimore, which is a very big medical school. And the other is with Lanzhou University in China, and they have actually a predictive model that now includes temperature and humidity in their predictive math, and the way the model is structured. I think the other collaboration that we're doing now, which could be interesting, is that because temperature and humidity can be measured by satellites with a lot of accuracy globally, you can actually use satellite measurements as a way to early detect conditions for COVID spreading, and that's the one that has us a little bit more excited because if you're able to predict conditions with about 2 weeks in advance, which is kind of what we're looking at now, conditions that could lead to increased COVID spread, then you have a little bit of time to maneuver logistics and practical measures.
You mentioned before. I mean, the spread of the pandemic, it depends, of course, on the spread of the virus that could be affected by temperature and humidity, but also for the mobility of the population.
Right.
So have you thinking or thought on modeling this, or are you advanced in that sense?
So of course, the primary mechanism, or dominant mechanism of all, is human to human interaction. So if you're actually able to simulate several scenarios of mobility. So for example, if you impose restrictions, if you impose social distancing, if people wear masks, which is a way to, it's a very effective measure to cut the human to human interaction. And what every model is telling you, of course, and the models are converging pretty well, is keep your distance, use masks, and socialize as less as possible. So try to avoid large distances. Every single model out there will do this. I think the added ingredient of all of this is that if you are within a temperature and humidity range of as I described, the conditions can be relaxed a little bit or need to be tightened a little bit, depending on which part of that environment you're in. So we're being careful and not saying it is only temperature and humidity. It isn't, but it does have an influence.
So that means that we can expect a reborn of the virus in our latitudes in autumn or November, December.
It could, so it could. It could, and we do expect a resurgence of the virus because everything points to the fact that this is going to be a seasonal virus, so it's going to come and go, like influenza, for example, which is the one that's probably closest to it. And I think that because we have very good ways to predict weather and climate to some degree, we should, we're already telling people that, come November, come early December in the Northern Hemisphere, you should see a resurgence. If you're prepared, if you take the social measures that are needed, you can actually minimize the impact. And that's an important finding, because up until maybe 6 or 8 weeks ago, we were thinking that this would just go away, right? It's not going to go away. It's going to come back. We need to be ready. But we can be ready, and we have plenty of warning. There's no excuse for not being ready now for
Yeah,
something that's going to happen in
yeah.
November, right?
Yeah, very interesting. Your research, Fernando. What is next? What are you planning to do next?
Yeah, so we have so like any researcher, we're writing research proposals to several organizations. I think the one that I'm most interested in seeing through is this that I was mentioning about using satellite measurements to predict these outbreaks, because the interesting thing about the outbreaks is the following. See, outbreaks, if no one has the disease, or only a few people have the disease, then temperature and humidity are really important, because they actually make the virus more available, right?
Yeah.
Of course, once people get infected, then the spreading depends on human to human connection. But the outbreak itself, it's very dependent on temperature and humidity. So what we need to avoid is having, first of all, having people concentrated in places where you're going to get that temperature and humidity, even if they're not infected. Having people concentrated. So if we have a very good set of measurements of temperature and humidity, we should be able to say, correct. So manage mobility.
Yeah. Okay. Very interesting. I hope you get the funds to do that research that you are planning. And finally, Fernando, as I mentioned before, this is the Water Action Platform. We have around more than 800 people, water experts, utilities connected. They will have the opportunity to listen to you. What you have any special message or?
I think no, it's important. I think the as stewards of water, which is a vital resource for the entire world, we have to play a role in helping stop the spread of the disease to the extent that's possible. So I think we are in the process of putting a predictive system on the web. It's something like Johns Hopkins has now for the actual data, but we actually want to have a 2-week predictive, so a 2-week forecast of disease that's worldwide. So I'll be looking to your organization to maybe help spread and disseminate this information, because I think it matters to everybody.
Of course. Yeah, it's important to know. I mean, it's a very interesting research, very interesting approach to look at the spread of the pandemic. So, Fernando, thank you for everything. Thank you for making you available, and it has been a pleasure having you today here. And good luck. Thank you. Bye-bye.
Well, thank you, Victor. Thank you, the Water Action Platform, for hosting me, and maybe I can come back a few months from now. We can talk about what we actually found. So
perfect. That would be perfect.
Yeah.
Okay.
Wonderful.
Bye. Thank you.
Thank you. Bye. Thank you.
Bye.